Time density. Time is the meter of our lives. It seems like the most reliable and constant variable in all of our plans. We live our entire lives here on the surface of the earth, where time appears constant. However, throughout the universe, time isn't constant. It varies greatly from essentially frozen to infinitely fast, depending on where you are. Areas of space with more mass, therefore more gravity, move through time slower than areas with less gravity. Time speed is only relative to other time frames. All time frames feel the same. You wouldn't feel like you are going faster or slower through time if you moved between different time frames. The only indicator would be that everything else in the universe speeds up when you slow down and slows down when you speed up. Space-time is denser near large objects in space, like black holes. Dense space makes time slow down, which makes everything slow down, including the spin of atoms and the speed of light. Dense space also attracts mass. There is more space in dense space. With gravity, you can fit large areas of space into small areas, while still being the same size. The speed that you move also affects your time frame. The faster you move, the slower time moves, until you reach the speed of light, where time stops. A traveler moving at the speed of light would see the universe in extreme fast forward. Atoms can't move at the speed of light, only electromagnetic energy. If an atom is forced to move at the speed of light, it becomes electromagnetic energy. Here's a thought experiment. We will start 3 identical clocks at the same time, in 3 different places in a galaxy. Because of the difference of gravity in each of the places, they all move through time at different speeds relative to each other. Then if you were to visit each clock with your own clock, all of the clocks would appear to be working at normal speed. Your clock's time would be in sync with the other clocks in the time frame you occupy. From the outside of the galaxy, the middle clock would be moving much slower. The clock near the center of the galaxy would appear almost stopped. Then when you visit the middle clock, the clock on the outer galaxy would appear very fast. The clock near the center of the galaxy would appear slow but not stopped. When you visit the clock near the black hole or center of the galaxy, the middle clock would be moving much faster, and the one on the outside of the galaxy would be moving so fast it would be a blur. Of course, you can only do this experiment in your mind. The distances would be too great to wait for the light to arrive to your eye. Relatively speaking, time is stopped in black holes. And on the opposite side of the spectrum, if you move outside of the universe, far away from all gravity, time moves infinitely fast. You can estimate your relative time frame by taking the mass of the object you are closest to, multiply by how close you are to its center, add this to the closest star and the closest black hole, and the center of the universe. All of the mass of these objects and their distances, all of the mass of these objects and their distance from you, all of the mass of these objects and their distances from you add up to determine your time frame. So if you think about it, you are actually being affected by the center of the universe.